Okay, so now we have power of a quotient for some more complex examples. Power of a quotient says a over b all to the x power. That x gets distributed to the numerator and to the denominator, so you have a to the x over b to the x. All right, so some more complex examples. This first one says 11 times this power of a quotient. There's nothing I can do with the 11. I'm just going to circle it with the green marker, and I'm just going to bring that guy down right now. We're not going to touch him at this point. Next, I'm going to concentrate on my power of a quotient. I'm going to distribute that 6 to both the numerator and the denominator. When I do that, this would be multiplied by 2 to the 6th power over m to the 6th power. Again, I'm just going to bring that 11 down, not doing anything with him at this point. Times by, I'm going to calculate 2 to the 6th power, which is 64, over m to the 6th power. All right, so that's simplified as best as I can, that power of a quotient. So now I'm going to make this a fraction by putting a 1 under it. And now I'm going to multiply the numerators. So I have 11 times 64. And 11 times 64 is 704 over, and now I have on the denominator section 1 times m to the 6th, and that makes it, oops, m to the 6th. So my answer would be 704 over m to the 6th. Now, I told you these were more complex. Ooh, doggy, that one looks really complex, this next one. Again, power of a quotient. So I'm going to do some distributing first. Be very careful. Make sure you distribute it to the coefficient, the a and the b in the numerator, and then the coefficient, the a and the b in the denominator. Wow, complicated for sure. All right, so I'm going to rewrite. So I got negative 2 to the 2nd power times a to the 7th to the 2nd power times b to the 2nd power, and this is really like b to the 1st because there was nothing there, over, I have 5 to the 2nd power times a to the 2nd, all to the 2nd power, times b to the 2nd, all of the 2nd power. So lots of distributing going on. Next, let's do some simplification. So negative 2 to the 2nd power would be 4. A, and then 7 times 2 is 14. And then b, and 1 times 2 is 2. All over. 5 times 5 is 25. And then I would have b to the 2 times 2, which is 4. And b to the 2 times 2 as well, which is 4. Now, some more simplifying going on. Now you're going to look at each one individually. I'm not going to take the time to rewrite that, but 4 over 25 cannot be simplified anymore, so I'm going to leave it. 4 over 25 times by. This is a division. Oops, did I write? Sorry, it should have been a here, not b. So keep the bases the same, and because this is division, I subtract the exponent, so 14 minus 4 is 10. Keep the base the same, subtract the exponents, and I have 2 minus 4, which gives me a negative 2. So we're going to have to take care of that negative exponent here in a minute, too. So I have 4 over 25. Let's make these fractions. And so I'm going to leave 4 over 25. Nothing I can do with that. I'm going to leave a to the 10th over 1. But here's where I have to take the reciprocal because it's a negative exponent. So I have to flip it. Next, I'm going to take everything in the numerator and multiply it together. So 4 times a to the 10th would be 4a to the 10th. And then take everything in the denominator, which is 25 times 1 times b squared, which would be 25b squared. And ladies and gentlemen, that is your answer. You could approach this a couple of different ways. Maybe you do the quotient of powers first and divide, and then apply this power of power, but this is kind of how I choose to do it first. Choice is yours.